Good morning to all. So today I came here with the second lecture of chemical reaction and equation. As we have studied till now that what is chemical reaction and then what is product, what is reactant, which is in the grade 10 level. So today we are going to study about chemical equation, right? Very important chemical equation and how to balance it. The main topic for the today, how to balance a chemical reaction. This is a very important topic where we will learn how we can balance chemical reaction very easily. Right. Till now, you might have studied in a book that there are very lengthy processes are there for which you learn how to balance. But I will just make you study very small concepts so that you can easily learn the equations how to balance. Right. So today we are going to discuss about chemical equation. So first question is this, that what is chemical equation, right? So chemical equation is a process through which, it is a kind of symbolic representation. Okay. We can say that the symbolic representation, the symbolic representation of chemical reaction using some symbol, formulas, arrows, etc. Right. So, in a very short term, we can say that the chemical equation is nothing but a symbolic representation of the chemical reaction, and we represent this chemical reaction using some symbol, formula, or arrow, something like that. Right. So, we will first discuss that what kind of symbol we generally use to represent a chemical reaction. So, that will be like this. See, there's an arrow. Suppose this is a reaction A plus B. This arrow is C and D. So this arrow represents a forward reaction, right? Forward reaction. When there's the two reactants are reacting together, we all know that in arrow where we have a tail side, and that side represents reactant. Right? So this is the reactant side, and these are the mainly species which take parts in reaction. And as this reaction are carried out, it can be a kind of flame or something, or in any condition if it is there, we write it here. Okay, either in downwards or above the arrow, and whatever things which we get, that is considered as product, right? We all have discussed what is reactant, what is product. Reactant are the species in which they combine together to form a new product with new properties. And products are the substances or the compounds which are formed when the reactant reacts together, right? So this is the main definition of product and reactant, and this is how reactions are carried out. Suppose there's an arrow I have writing here as this arrow. This arrow represents that when product is formed, this can be turned into a gas, right? So this arrow denotes the gaseous state of a product. And then this delta sign is represent the heating process or the combustion process. We put it here, this delta sign. This arrow represents the forward reaction, and if I'm writing like this represents the backward reaction. There are many reactions, okay, which when they react together, they form product, but after instant of time, we get back to its initial state. So that is and this together is considered as equilibrium position, right? This all we will discuss in standard 11. So in today's class, we are going to discuss just about how to balance an equation. Now see, starting it with a very small example. We all know that hydrogen reacts with oxygen to form water, right? We all know this, that there are two species that consider hydrogen and oxygen. When they combine, it forms water. Now, why it is important to balance a reaction? See, chemical equation is based on a law called as law of conservation of mass. See, anyone can ask you that why we should balance a reaction. What is the reason? What is the need of balancing a reaction? And how you can state whether the reaction has been balanced or not. So, what is the basic reason behind it? See, there's a law, conservation of mass, which states that mass can neither be created nor be destroyed. It only transforms from one position or from one type to another type, right? Where the mass remains the constant. So, on the basis of this principle, the reaction has to be balanced. Suppose, example, this we all know that this reaction is unbalanced, but how we can check it? We can check it like this. We all know that the atomic mass of hydrogen is 1. So there's a 2 atoms of hydrogen. So 2 into 1 plus 2 atom oxygen, and 1 oxygen mass is about 16. So here you get 2 plus 32. This is 34. Right? Suppose I'm taking a unit a gram. So 34 gram. Now here you can see that 2 unit of hydrogen, and then atomic mass of one hydrogen is 1 plus oxygen is 1, so 16, then this is 18 gram. Now you can see that only 18 grams of water is formed, where the 32 gram of species are reacting together. So from here you can state that conservation of mass is not there, because mass is somewhere distributed somewhere, right? So in order to see this, we need to balance. And once we'll balance, you can understand that how the reaction is there. Now, what I'm doing, I'm writing in another page so that it can be, we can see. See, this was the reaction. H2 plus O2 gives H2, right? See, now what I'm doing, I'm balancing it. This is very important, right? This is my convention that how to balance a reaction. See, what we'll just balance all the particles on both the side in equal state. Here you can see that there's a 2 atoms of hydrogen. Here 2 atoms of hydrogen are there. So this equation is this atom is balanced. But when you look to this oxygen, you'll see that there's a 2 oxygen and 1 oxygen is on the right hand side. So we can see this is the arrow on the reactant side. We'll call it as LHS, left hand side, and after the arrow we can state it as LHS. Now here you can see that 2 oxygen is there, 1 oxygen is here. So this is not balanced. So we need to balance it first. Now what is my convention? See, in any of the reaction, you will see that whenever there's an odd number of atom present, right? What you do, you make it even. Make sure that you make it even wherever side, either to this side or that side. If odd number of oxygen is there, you need to balance it, right? So here I'm doing a balance thing. So here you can see that there's an odd number of oxygen. So this term is called as coefficient term. Only we will put any number, so that can be multiplied with this 1 oxygen and it will be the same, right? Suppose I'm putting it 1. So 1 into 1 oxygen will be there. So I'm putting it 2. Now what you see that 2 into 1 oxygen, how many oxygen? 2 oxygen, right? So 2 into 1, how many? 2. And here is 2. So 2 balance. Now you see hydrogen is disturbed, because 2 into 2, 4 hydrogen is there, and here is 2 hydrogen there. So how you will make it? So here we'll put it to another 2. Now you can see that 2 hydrogen, 4 hydrogen left hand side, 4 hydrogen right hand side, and left hand side oxygen, you can see that 2 atoms are there, and the right hand side oxygen is 2, right? So this is the main thing which you might have learned. Now what we will do, we will go with some examples, and then we will learn how to balance a reaction, right? So another example I'm writing. Suppose this is Fe. This is Fe. right? Fe plus Fe plus H2 SO4 gives Fe 2 SO4 whole 3 plus H2. This is a very important reaction. You can see that. Then the iron is reacting with sulfuric acid and the salt is formed and a hydrogen gas is dissolving in the reaction. So we need to balance it. So here you can see that only one, Fe is there, and on the right hand side you can see that two Fe is there. So what we are doing, the odd number of atom is left hand side. So we are putting it 2 here, right? Now 2 Fe is balanced. Now you can see 2 hydrogen is balanced. 1 sulfur, and here is 3 sulfur, because see, SO4 whole 3, this 3 will be multiplied with this sulfur. So how many sulfur? 3 sulfur, right? So here I'm writing it 3, right? So now sulfur valence, come to oxygen. How many oxygen? 4. 4 3 is 12. 4 3 is 12. This is valence, this is valence, right? Now what is disturbed? This is hydrogen. How many hydrogen? 6 hydrogen. So what we will write? We'll write 3 here. Now this is balanced. So similarly, there are many questions are there in the book. You can solve it, and whenever you have any problem, you can write in the comments, so that I will be teaching you that thing, so that it can be easy for you to understand the reaction, how to balance. Okay, thank you so much. Thank you for being here. Thank you so much.